Okay, it's another time I would like to take this opportunity to welcome all students into this very interesting moment. And I would like to just tell you that today we have a very interesting module in electronics engineering and telecommunication engineering that's called electronics drawing. And I would like to take this opportunity to welcome all the physical students that I have in this class, and even some online students who are not physical with me. And I'm very happy to have you today, and I would like to tell you that I have a very important information that to share with you. If it's the first time to meet me, well, my name is Olenjolai, Moko, Tayai, Losingo. Simply just you can call me Olenjolai. I am a Tanzanian, and I'm here actually to transform students in my beautiful country, and even some students who are not Tanzanian. Because we have some students from Rwanda, we have some students from Congo, we have some students from Europe. And actually that we are training our university to impact and add something in academics. I have some physical students who are actually pursuing ordinary diploma in electronics and telecommunication engineering, and they're very happy, and this is their first lecture. And actually they told me that they would like to learn a lot about electronics drawing. So I would like also take this opportunity to welcome you. It's the first time or second time. This is a very interesting module. Whenever we talk about engineering, we cannot talk engineering without the art of drawing. In engineering, actually, we have to identify a problem. And once we identify a problem, we might have to do the hypothesis of the solution. And once we do the hypothesis of the solution, then we have to think that how we can represent that solution. And one of the techniques that we use oftenly in engineering, whether electronics engineering, or mechatronics engineering, or telecommunication engineering, or biomedical equipment engineering, or maybe it's electrical engineering, or mechanical engineering, or civil engineering, we always sit down and draw different diagrams. So that's why that this module, or this subject, or this course is very important. We are going to teach you how to draw. We are going to teach you how to read drawings that have been drawn by other engineers or other expert technicians. So it's a very serious module, and actually we have a sequence or a number of lectures and even workshop and exercise to make sure that we equip our students on how to draw and on how to interpret and read the diagrams that have been drawn by other engineers. So one thing which I want to tell you that in advance, if you have a vision that you want to be an engineer, I want to tell you that in advance, and you remember me, that you have to be competent in drawing. Because engineering is all about drawing. If you want to say that they want to solve a particular problems, maybe in transportation, you have to sit down and draw. I want to tell you that whenever you see the tall buildings or the normal buildings, there's no any buildings without architectural drawing and structural drawing. Whenever you see any electronics equipment, such as a mobile phone, there is no any electronics equipments, whether that it's the small electronics equipments or device, or it's a large, or it's a complex, such as, let's say, supercomputers. You cannot have them without having drawing. So that's why I have realized that it's very important to give you this introductory information in order for you to take serious and actually to take this advantage to learn step by step and practice what we are going to teach you. So well, because we'll be having some other lecture. We'll have lecture 1, lecture 2. This is lecture 0. Okay? So I will tell you some other importance and necessity of taking this course. Maybe another question that you might be asking yourself, this course is for whom one? Well, this course is for anyone who loves electronics engineering and telecommunication engineering or biomedical engineering. So whether you are a graduate of the Form 4 and you wish to go for maybe to pursue ordinary diploma in electronics and telecommunication, they are waiting. Maybe you are in a waiting zones, maybe 1 year, especially in Tanzania, you may take this course. Or you are ordinary diploma students, whether NTA level 4, first year or second year or third year, this course is very important. Maybe also you are undergraduate or bachelor degree students, whether first year, second year, third year, fourth year, this course is very important. And however that in introductories in lecture 0, 1 and lecture 2 will actually teach you the general idea. But later on we'll keep focus on electronics engineering, telecommunication engineering, electrical engineering, because the diagrams that you are going to draw, we use them. And actually that you can find that some of them are the cross-cutting. So you should have expectation. And if you are a beginner, well, this is the good opportunity because I'm going to teach you as a beginner and then I will add values until you become intermediate students in drawing or electronics drawing. And later on, you might even become an advanced student. So there's so many requirements in order for you to understand this course. But today I will not mention because I want to give the general introduction and later on I will tell you about the tools that you need for you to go through. But well, we are going to have some paperwork and also we are going to have some computer work. That's what I want to tell you. So in this course, actually we are going to draw on paper and we are going to draw on the computer. Okay? So let me appreciate some physical students who are in this class and let me greet them. Good afternoon, electronics and telecommunication students. Good afternoon again. Good afternoon, are you ready for lecture 0 of General Introduction of Electronics Drawing? Yes. Wow. So the module is called the electronics drawing. Say electronics drawing. Electronics drawing. Physical students and even non-physical students, I will ask you to pronounce these terminologies and most of the keywords that we are going to discuss, because once you pronounce, you are right in your mind. Once you pronounce, you are right in your mind. So for instance, myself, when I'm teaching and I pronounce those terminologies right up in my mind. Okay? So you should be happy and you have to pronounce, even you are alone, you're a group of students. Yes, you have to pronounce them and you have to enjoy them. Again, students loudly say electronics drawing. Electronics drawing. I didn't hear. Say electronics drawing. Electronics drawing. Again, loudly. Ladies yourself. Boys, keep quiet. Say electronics drawing. Electronics drawing. Gentlemen, say electronics drawing. Electronics drawing. Again, gentlemen. Electronics drawing. All the students say electronics drawing. Electronics drawing. Well, so we have a number of we have almost 7 chapters in this module. The first one is called the General Introductions of Electronics Drawing. Say General Introductions of Electronics Drawing. General Introduction of Electronics Drawing. So this is the introduction, but it's very general. And you have to listen and take considerations on that. Okay, so in general introductions of this module, we say that, yes. So we say that this is, just we call it sub-enabling outcomes, yes, model names and whatever. So we say that general introduction, so the concept that you are going to start, general introduction of electronics drawing. Electronics drawing according to Dar es Salaam Institute of Technology. Simply call it DIT curriculum. So this is the general introductions of electronics drawing according to Dar es Salaam Institute of Technology, or DIT's curriculum. Curriculum in, write down, Department of Electronics and the Telecommunication Engineering. So when we have been in nursery education, primary education, and secondary education, we have been guided by a manual or by an official or formal document that we call it syllabus. Say syllabus. Syllabus. Say syllabus. Syllabus. We had the syllabus, for instance, of physics or level. We had the syllabus of chemistry or level. We had the syllabus of biology or level. We had the syllabus of basic mathematics or level. When it comes for the tertiary, or say the we call it level of education, tertiary education, or higher learning institution, higher learning college, higher learning university, we don't call them anymore. We don't call those formal documents syllabus. We call them curriculum. Say curriculum. Curriculum. Say curriculum. Curriculum. So curriculum, this is the official document that gives guidance and give guidance to the lecturer or teacher of the particular subject, and also to the students who are learning. Because in a higher learning, we are not hiding the information. We want the teachers to be guided in order to know that what are the contents to deliver to the students of the first year or second year or third year in ordinary diploma. But also we want the students, because you have an access of the internet, you have an access of the library documents, to know what should you learn. Are we together?
Yes.
Are we together?
Yes.
Let me repeat. In learning, for instance, in nursery schools or nursery education, say nursery education. How many of you who have gone through nursery education, raise up your hand? For myself, I didn't get. Raise up your hand if you have gone through nursery education. Well, congratulations. Myself, I didn't get that chance. I began standard 1. So do you see that? How you are more educated more than me? So in nursery school, actually you are not taught that what you are going to learn, right? First of all, by that time, you are thinking about what? Playing, right? All the time. Playing. And even you can go to school and forget the exercise book at home and a pencil. Are we together? Yes. But once you have gone for primary education, your mind is still young. You cannot teach yourself. So the teacher might be the one who knows what to teach you in mathematics, what to teach you in science and technology, what to teach you in English language, what to teach you in Swahili subject, what to teach you in social studies. That we call it in Swahili, Maarifa Jamii. Okay? When you went for the secondary education, at least some of the teachers open your mind. What should you learn in chemistry form 1? Because from that time, at least you are kind of a teenager or a youth. You can learn. You can prepare yourself before the class. Are we together?
Yes.
So now you are an ordinary diploma student. So we have a responsibility as your teachers to tell you what should you learn in this module in order for you even to go yourself. Whether I come in the class or I don't come in the class, you know what should you cover. And this one actually gives you the general overview of the course. And if maybe some of the contents are missing according to what you need, you may go outside or beyond the box or outside the box. Are we together?
Yes.
Are we together?
Yes.
So there is no secret anymore in this level. We tell you what you should learn. And we tell you what are the questions, or where are we going to ask you questions in the exam. Are we together? So you can find that this education is kind of simple. Okay, so the module name is electronics drawing. This is very important. So the following, so what I'm going to present to you I am not the one who prepared it. I extracted it from the DIT or Dar es Salaam Institute of Technology curriculum. So this is what I have been given to teach you, or I have been given as a guidance to teach you, and this is what you have to learn, to use to learn. Are we together? So it's your right to know what should you cover in that module. In case you don't know, you may ask your respective teacher of the respective module. It's your right. Say it's my right. Say it's my right. Yeah, so if you don't know, we like to say that you are very thorough because you are blind. It's not the level that Olenjolai is the one who knows what to teach. No, you may know that the next topic will be this one. The next topic from the first day. Okay? So one of the important information that you have to know, something we call the module code. Say module code. Module code is just like a registration number. Every student in this class, or every college or institution students or higher learning students has his or her registration number. So even the modules or the courses in higher learning, we identify them so we know them according to the modules code. Right? Right? Module code. Say modules code. So the module code of this module is ETT 04112. This is the module code. So it is ETT 04112. Okay? Those letters, how many letters do you have there? Hello? How many letters do you have there? 3 letters. How many numbers do you have here? Each letter has a meaning, each number has a meaning. E, so you can write, E standing for electronics. T standing for telecommunication. And this T is standing for technician. So it's electronic and the telecommunication technician. That the meanings of ETT. Say ETT. It's abbreviations of what? Say it. Electronics. That the voice of more than 40 students. ETT, it's an abbreviation of what? Electronics. No, electronics and telecommunication technician. Say it. Electronics and telecommunication technician. Then 04, this means that NTA level. So 04 represents what? NTA level. So NTA level what? NTA level 4. Are we together? Yes. Are we together? Yes. Then this number 1, this one, do you see? Stop writing, stop writing. This one represents that this module is for semester 1. I know that you met with different courses, but you don't know what do they mean. The third digit represents what? It's what? If the module is for the semester 2, you will never find 1, you'll find 2 here. Are we together? Yes. Are we together? Yes. This representing about the curriculum, we call it the module curriculum's number. And these 2 represent that the number, this number 2 represents that this is the second module according to the arrangement in the curriculum. Where that the first module, its module code is ETT 04111, which is called the basic electronics. So in terms of the fundamental arrangement, basic electronics is the first module, important module for you, and this one is the second one. Are we together? Are we together? Yes. Class, I said that you have to support me. Then, another important information, number 2, every module have a number we call T credit, or have a figure we call T credit. Say credit. Credit. Say credit. Credit. Credit is very important whenever you want to calculate GPA. Grade, 20, average. So the number, each module has a number of credits. So electronics drawing, it has a number of credits. So the number of credits for this module is 9. We have in our departments of electronics and telecommunication engineering, we have some modules that have a module has a credits of 6, credits of 9, and credits of 12. Basically, electronics is module, it's a number of credits is 12. This one is what? 9. Say 9. 9. Then, number 3, the number of learning hours per week of this module. The number of learning hours per week of this module, it's 5 hours. So whether you are an independent student, whether you are maybe O-level graduate students, make sure that in a week you just find 5 hours to learn electronics drawing. How many hours do we have in a week? You don't know? Because you don't take care about time. How many hours do you have in a day? 24. 24 times. How many days do you have in a week? Do you remember the song? How many days in the week? 7 days, 7 days, 7 days. So even you are singing, you are not there. Where are you? Okay, so 24 times 7, what do you get? 168. So in a week we have 168 hours. How many hours should you spend to learn about electronics drawing? 5 hours. It means you have to be taught electronics drawings in 5 hours. And they have also to take some other 5 hours to review what you have been taught and even to learn the new concept. So 5 plus 5 makes what? 10. So in the week, this module just need you are 10 hours. So ask your neighbor, how are you going to spread those 10 hours in a week? Ask your neighbor, how many hours will you spend to learn electronics drawing on Monday, Tuesday, Wednesday? Ask your neighbor. Talk to your neighbor now. Yes, from the first day. Learn from your neighbor. Whether 0 hour, 1 hour, 2 hour, 10 minutes. Then, after presenting the module code, say modules code. What the module code, so you have to bear in your mind, because it's just like your registration number. Your registration number you have to keep in your mind, right? In case of the higher level learning institutions or education, you have to bear this module code, right? Yes. So what the number of learning hours per week? But this is number of learning by teaching. And then you should have 5 hours to review what you have been taught, because you know yourself. No revision, no memory. Then, another important, we call it sub-enabling. Sub-enabling outcomes. These sub-enabling outcomes in our level syllabus, we call it a specific objective. Sub-enabling outcomes of electronics drawing. So this is the vision. What vision do we have in electronics drawing? What should you achieve? What should you learn? What should be your target? What should be the requirement for you in order to say that now I'm competent in electronics drawing? So according to the DIT curriculum, there are 60 sub-enabling outcomes or specific objectives that myself as a teacher, I have to make sure that I achieve to teach you, and yourself as the students, you have to make sure that you achieve them. Are we together? Yes. Simply call that this is the plan. This is the guidance. That guidance in higher level institution, and especially for the competence-based education training that we call it CBET. CBET is abbreviations of competence-based education training according to NACTIVATE. NACTIVATE is abbreviations of National Council of Technical and Vocational Education Training. In Tanzania, we have CBET and we have knowledge-based. TCU focus on knowledge-based. NACTIVATE focus on CBET, competence-based education training. Say competence-based education training.
Competence-based education training.
Again, say it loudly. You came in departments of electronics and telecommunication engineering at Dar es Salaam Institute of Technology for the sake of competence-based education training in ordinary diploma of electronics and telecommunication engineering. Whenever we talk about CBET, it means that this is called practical training, more practical training rather than theoretical training. Knowledge-based, it's more theoretical training rather than practical training. Are we together? Yes. So we say that according to the DIT curriculum, there are 60 sub-enabling outcomes of, that a student has to achieve in electronics drawing. Once you complete this course, you have to achieve the following 60 sub-enabling outcomes. Say sub-enabling outcomes. Say sub-enabling outcomes. Say sub-enabling outcomes. So he said that according to DIT's curriculum of 2020, there are 60 sub-enabling outcomes that a student has to achieve at the end of learning this module. So if you want to show that we are serious electronics and telecommunication engineering students, or a serious electrical engineering students, or a serious computer engineering students, and they want to be competent in electronics drawing, you have to make sure that you achieve the following 60 sub-enabling outcomes. This is not a limit. They just suppose that the students has to know. You may go beyond that. If I could be you, I could even establish some other 4 sub-enabling outcomes and make them 10. Because you're allowed to go beyond there or outside of the box. This is inside the box, right? So ask your neighbor, how many sub-enabling outcomes, how many personal sub-enabling outcomes you are going to add to make 10? Ask your neighbor. Ask your neighbor. It's time for you to talk with your neighbor. We know that your neighbor can talk. So test him or her that he or she can talk. And not just talk anything. Talk meaningful information. Because if you give him or her a chance to talk anything, he'll get surprised. The first is sub-enabling outcome. A student should be able to employ electronics drawing. A student should be able to employ electronics drawing knowledge to describe electronics drawing in constructing electronic circuits. This is the first sub-enabling outcome. A student should be able to employ electronics drawing knowledge to describe electronics drawing in constructing electronic circuits. Stop writing. Listen. Stop writing. Look and listen. A student, it means that in this model you have to make sure that you are able to employ, say employ, say employ, electronics drawing, because there are different skills in electronics. You may have electronics drawing skill. You may have, hello, I said stop writing. Please, you have to make sure that you invigilate your neighbor on your left-hand side and right-hand side, because that's why that you chose that good neighbor. I said, whenever you are learning this model, you have to be able to employ electronics drawing knowledge. Say knowledge. Knowledge. Say knowledge. Knowledge. Say knowledge. Knowledge. So we have electronics drawing knowledge, we have electronics analysis knowledge, we have electronics design knowledge, we have electronics modification knowledge or advancement knowledge, we have electronics troubleshooting knowledge. So you have different knowledge in electronics. But for this one, you should be able to employ electronics drawing knowledge to do what? To describe what? Electronics drawing in what? Constructing what? Electronic circuit. So this module will not teach you about electronic circuit. This module will teach you how to employ electronics drawing knowledge to describe what? To describe what? Electronics drawing in constructing electronic circuits. Are we together? Yes. We are going to read loudly the first sub-enabling outcome in order to write in our mind. Loudly. Tell your neighbor, we are going to read that first sub-enabling outcome loudly. Tell. No. You have to speak loudly. If your neighbor will not speak loudly, next time don't sit with him or her. Don't sit nearby him or her. 1, 2, 3. Let us go. Let us read the first sub-enabling outcome. So you yourself, at the first year ordinary diploma students, you have to know how we construct electronics circuits. That is not the purpose of this course. You have to learn how to construct electronic circuits, especially from basic electronics. And then myself, I have a responsibility to teach you how you employ electronics drawing knowledge. That actually I have to teach you about this electronics drawing knowledge. How do we draw block diagrams? How do we draw schematic diagrams? How do we draw circuit diagrams? How do we draw layout diagram? How do we draw flowchart diagrams? How do we draw wiring diagram? So those are the knowledge. And then yourself, you have to know. For instance, if you wanted to construct electronic circuits of the operation amplifier, or let's say of the maybe of amplifier, what are the requirements? So in this course, actually that you have to know how to construct the circuits. Myself, I have to teach you how to draw that circuit that you wanted to construct. Class, are we together? Yes. The second sub-enabling outcome. Tell your neighbor the second sub-enabling outcome. The second sub-enabling outcome is students should be able to use electronics knowledge to interpret component schematic symbols in implementing electronic circuit. in implementing electronic circuits. So that's the second sub-enabling outcome according to DIT curriculum. Use electronics knowledge to interpret component schematic symbols in implementing electronic circuits. Okay, stop writing. So the keyword in this sentence are the following. The first keyword is use. Say use. Use. Say use. Use. Ask your neighbor, do you know the meaning of use in Swahili? Ask your neighbor to remind you, use in Swahili. How do we interpret, how do we translate use in Swahili?
How do we translate use in Swahili?
So answer, and then you have to answer again because you've been asking and then you have to answer the question. Use ni kutimiza. Use is? So you as a student and myself as a teacher, I have to teach you. Stop writing, I say. Look on the blackboard and listen. Use how to use electronics knowledge. Say knowledge. Knowledge. Say knowledge. Knowledge. You have to be able to use electronics knowledge to interpret. Interpret what? Component schematic symbols in implementing electronic circuits. So you cannot draw electronics diagrams if you know the schematic symbols of electronics components. So you have to know thousands schematic symbols of different electronics components in order to use them in your drawing. But in order to understand the electronics drawings made by other technicians or other engineers. Say schematic symbols. I can say schematic symbols. Say schematic symbols. Very important. So for instance, schematic symbol of a resistor, you know, this is the schematic symbol of the resistor. So whenever you see this one, well, you know that is the resistor. The schematic symbol of variable resistor, this is the schematic symbol of variable resistor. The schematic symbol of maybe a capacitor, this is the schematic symbol of polarized capacitor. So whenever you see this symbol, or you want to draw a polarized capacitor, you have to know it's a schematic symbol. Otherwise, you cannot draw the schematic diagram. You cannot draw the circuit diagrams of that particular system. What the meaning of schematic? That the particular topic we'll discuss it later. Schematic, we have two topics within this sub-enabling outcome, which I'll mention. The first one will have a topic specifically called schematic symbols, because I have to teach you. I should not expect miracles that you sleep and then wake up, you know the schematic symbol for operation amplifier. Or maybe you sleep and then you wake up. No, we have to teach you. Right? So within that sub-enabling outcomes, I developed the two topics or two chapters. The first one is called the schematic symbols. And the second one is called the schematic circuit diagrams, or schematic and circuit diagram. We call it schematic diagrams, or you may call it, because there's a difference between schematic diagram and the circuit diagram. But sometimes we can have schematic circuit diagram, which is actual combinations of the two. Combinations of schematic diagram and circuit diagram. Are we together? So I will answer that questions. What are the meanings of schematic symbols? What are the important schematic symbols that we have? And what are the just electronics components that you have to know the schematic symbols? But you have to understand that in this module that this module, according to these sub-enabling outcomes, it asks you to have some knowledge before me teaching you electronics drawing. And then you have to use it. Nasema hivi, ukiangalia hizi sub-enabling outcome mbili kwanza, zilivyoandikwa, zinatarajia wewe uwe na maarifa fulani ya electronics. Mimi nikufundishe namna ya kuitumia hiyo maarifa. Sawa? Mtu alikwambia kwamba employ electronics drawing knowledge. Maana yake unafahamu electronics drawing knowledge kwanza. Mimi nikufundishe how you employ it. Students, are we together?
Yes.
Are we together?
Yes.
Then when somebody asks you that use electronics knowledge, it means I have to teach you how to use. Not I have to teach. It doesn't mean that I have to teach you what electronics knowledge that you need to interpret the systematic symbols. Those are the weaknesses of our curriculum. Because we know that you had only one topic of electronics in physics form 4, and it was short and clear. And sometimes some students, they skip it because it's tough to understand. So we ask you to use something that you don't have it. So for we who have been called and you have passion in teaching, and for we who are teaching, who is actual teaching is our work of heart, and it's our daily work, and it's the one that it becomes a challenge, because sometimes it's difficult to ask you to use something that we know that according to the curriculum, you don't know it. Are we together? Are we together? Remember that in a higher learning, it's okay to criticize. Especially if you go for the postgraduate. The difference, for instance, in OD and BNG, you are seeking for understanding. When you pursue for postgraduate, means master study, or PhD studies, means doctor of philosophy studies, right? They are actual, you'll be learning how to criticize. So it's better to criticize when it comes for the high learning. Remember that if you don't know the importance of criticism, you might that undermine somebody who is correcting. Are we together? For instance, ask your neighbor. One of the things that your neighbor doesn't like is to be criticized. Ask him or her, do you like criticism? You know, criticism means that you say that my name is Olenjolai. Somebody say, no, your name is not Olenjolai. Because of this and this and this and this. So ask your neighbor, can I criticize your name? Do you like if I criticize your name? No. Why? Because you believe that your name is right. Number 3. We didn't read. 1, 2, hey! 1, 2, 3, let us read. 1, 2, 3, go. Very good. So you wrote something in your mind, right? Yeah. Otherwise, if you didn't read, you have just written. And then you are waiting 1 midnight to claim. Use. Use what? What knowledge? Electronics. Use electronics drawing. Claiming. It's a wonderful business. Then the third is enabling outcome. You have to be able to select drawing tools, and equipment in servicing electrical and electronics circuits. So the third is enabling outcome. A student should be able to select drawing tools, not any tools, drawing tools, and drawing equipment. Why? In order to learn how in servicing electrical and electronics circuits. Ask your neighbor, how many electronics drawing tools do you know? I say ask your neighbor, how many electronics drawing tools do you know? Ask seriously that question and wait the response, wait the answer. Don't ask any enjoying. So mention at least 5 drawing tools to your neighbor. Electronics drawing tools. As mention, don't say that I don't know. Do you see that? How is your neighbor? Is very interesting? Yes. Yeah. So your neighbor is giving you materials. So listen, stop writing, look and listen. A student should be able to select drawing tools. A student should be able to select drawing equipments. Why? In order to service electrical and electronics circuits. Hello, hello. What are you talking? You are looking what? Drawing tools. I know what you have been talking. Let us continue. Okay. So when you say that drawing tools and the drawing equipments, then we say that, remember the subject is electronics drawing. So you have to know electronics drawing tools and electronics drawing equipments. And you should be able to select what are the variety drawing tools in order to draw these particular diagrams. What are the appropriate drawing equipments that I have to use in order to draw these electronics circuits? Are we together? Yes. So you should be able to select. So what it means of select, it means that we have a lot of drawing tools, but you have to be able to select the appropriate drawing tools or drawing equipment for that particular drawing. Are we together? Yes. So, but once you select those drawing tools and drawing equipments, you have to be able to service. Say service. Ask your neighbor what the means of service, because the word servicing is come from the verb called this service, or the noun that called this service. So ask your neighbor, what do you understand about service? And the first expectation to your neighbor to give interpretation of service in Swahili, not in English, because because for the number of students, service is a vocabulary. So don't use English to interpret the meanings of service. Start in Swahili. Service in Swahili is, then you explain what you want to mean. And what the means of service? Tell us. What the means of service? What do you understand about service? Servicing. Huduma. Kwa hiyo kuhudumia circuit za umeme na za electronics. Huduma ya kwanza, ya pili, ya tatu. I see you. Okay, do you know the difference between a technician and engineer? You don't know the difference? Okay, go back and ask your father and mother. What the difference between a technician and the engineer? Because once you graduate in this, in ordinary diploma, then you become a technician. Once you graduate in bachelor or undergraduate studies in a particular degree, you become an engineer. Okay? So what the difference between them? And then you know that you have some of your classmates who have gone through VETA education, or vocational educational training education authority, VETA, right? Once they graduate NVA 3, level 3, because you have NVA 1, NVA level 2, NVA level 3. It's just like yourself. You have NTA level 4, NTA level 5, NTA level 6. So when the VETA students graduate, they become artisan. We call them artisan. Say artisan. Say artisan. So in any particular industry area, we have artisan, we have engineers, no, we have technician, then next you have engineers, and then you have professional engineers. Are we together? Yes. So the difference between engineer and technicians you may differentiate them in terms of responsibilities. The main responsibility of a technician, of engineer, is to design. And the main responsibility of a technician is to implement what has been designed by engineer. So that's why in this study, sub-enabling outcome, tell your neighbor, Olenjolai is still teaching about sub-enabling outcome. Because you might think that Olenjolai has gone to technician and engineer. No, I want to explain the necessity or the importance of this word servicing. So your primary responsibility, now in NTA level 4 and level 5, once you finish NTA level 5 successful, you become a basic technician. Once you complete NTA level 6, that's the third year, you become full technician. So your primary function is to implement and maintain and repair. That's the primary functions of the technician. So when you say that servicing, you as a technician, later on or through when you are going through your studies, you may be given a particular electronic circuit or a particular electric circuit, and then you'll be asked that please troubleshoot or find the problem and fix it. So that's what we call it. You'll be servicing that particular electric circuit or electronic circuit. Are we together? Yes. Are we together? Yes. Kazi ya engineer au ya mhandisi ni kubuni. Kubuni na kuunda. Kazi ya fundi ambayo namuita technician ni kutekeleza kile kilichobuniwa na kutengeneza kilichotengenezwa. Yaani maana yake kutengeneza kilichotengenezwa, yaani kurekebisha kilichotengenezwa kikafa au kikapata shida. Are we together? So that's why you say that you have to be able to select the drawing tools and equipments in servicing, not in design. Right? In servicing what? Electrical and electronics what? So this module will not teach about electric. Actually, according to these sub-enabling outcomes, this module does not have a responsibility to teach about electrical circuit and electronic circuits. It means there are some other modules has to teach about that. But I know that you just have a little and limited knowledge of electronic circuits. Are we together? Yes. Are we together? Yes. Hey, that's the truth. Number 4. I've just explained in detail about servicing because we have these words at least in 2 or 3 sub-enabling outcomes. That's why I just give you elaborations or clarification. Once you select number 4, you have to employ. Hey, we didn't read here. 1, 2, 3. Ready? Again, read it loudly and happily. You are making noise. Backbencher there, you'll be pronouncing yourself. Okay, 1, 2, 3. 1, 2, 3, go. Circuit. Others, they are just waiting what? Select it, and then now once you select, you have to know how to employ them. Drawing tools and the equipment in servicing electrical and the electronics circuits. That the first sub-enabling outcome. Stop writing. Look and listen. Stop writing. The first sub-enabling outcomes is called what? So employ, it means you should have a prior knowledge. of drawing tools and drawing equipments. Myself, and in this module, I have to teach you how to employ. Are we together? Yes. Employ what? Drawing tools. And what? In what? Electrical. So what I've explained here is actual. So in these subliminal outcomes, you have to select the appropriate drawing, electronics drawing tools and electronics drawing equipments. Oh yeah, Simba. In this one, you have to be able to implement, because you know that you can select, yeah? Always to select is simple, right? Yes. Ask your neighbor, can you select a good friend? Ask your neighbor, can you select your good friend? The answer might be yes. And it's always simple. The issue is to employ that good friend. Isn't it? Eh? The issue is not selecting. For instance, today you select a good neighbor. But later on, you may understand that you did the wrong what? Selection. Why? Because you have employed what you have selected. Now you did not employ what you have what? That's why whenever that we are reaching a particular point, I ask you that to employ your good selections of the good neighbor by asking him or her questions. That the way of what? Employing. Are we together? Yes. Are we together? Yes. 1, 2, 3. Read it. Employing tools and equipment in servicing electrical and electronic circuits. Good. Number 5. Number 5. A student should be able to use technical drawing. A student should be able to use technical drawing knowledge to interpret electronics drawing in servicing I know that it's Tanzania time, so you should not worry. You should not think about that. Think about electronics drawing. And I will think for your Tanzania time. Don't worry. Think about electronics drawing. And myself, I will think about electronics drawing and your Tanzania time. Not my Tanzania time, yours. Because yours is important. If you miss it, you say you are going to die. But for me, if I miss it, okay, I'm maintaining the shape. Okay, now we say that we are in 5 sub-enabling outcomes. So the vocabulary, the keyword is what? Use. Say use. And you told your neighbor the translation of use in Swahili. You know there are some students here who are good in English, but they are poor in Swahili. You know that? And there are so many students who are good in Swahili, poor in especially spoken what? English. If you ask them to... Okay, but you should not worry. You have to work hard. Use technical drawing knowledge. Say knowledge. Knowledge. To interpret electronics drawing in what? What? So actually, if you can summarize, there are only 3 words. Employ, use, select. Employ, use, select. Again, say employ, use, select. Employ, use, select. Again. Employ, use, select. Again. Employ, use, select. So use what? Technical knowledge that will acquire in basic technical what? Drawing. To do what? To interpret. Say to interpret. Interpret. What? And responsibility of technician is to do what? Servicing of what? Electrical circuits. And what? Electronic circuits. Are we together? Yes. 1, 2, 3. Read it.
Use technical drawing knowledge to interpret electronics drawing in servicing electrical and electronic circuits.
Number 6. The last one. A student should be able to employ electronics drawing tools to produce electronics drawing or electronics drawings in constructing electronic circuits. Employ electronics drawing to produce electronics drawings in constructing electronic circuits. That the sixth and last sub-enabling outcome according to DIT curriculum of 2020. I told you that I will present to you 6 sub-enabling outcome. This we call them formal sub-enabling outcome. But I told you to ask your neighbor how many sub-enabling outcomes you are going to add to those 6. And if your neighbor say 2, then ask him or her to write on paper those sub-enabling outcomes and show you next Monday. Yes, because the answer is not, actually we say that it's not just to say 2. Show us those 2. And then you can customize, is it? Yeah. Then in C6 sub-enabling outcome, we've been asking the same vocabulary, or the same verb in first sub-enabling outcome. We use that verb in fourth sub-enabling outcome, and it has been used in the 6th sub-enabling outcome. I said stop writing, listen, and look. Hello, my friend there. So we have been asked that, or I've been asked to teach you to employ electronics drawing tools to produce electronics drawings in constructing electronic circuits. So for this case, it is to interpret. Say to interpret. Say to interpret. Interpretation, this is very important word in science. We learn 7 steps of learning science. The first one, identification of the problem. For myself, I learned them in 2004 and 2005. And I still remember. The first one, identification of what? Of the problem. The second one, hypothesis, formulation. You forgot. The third one is called what? Experimentation. The fourth step is what? Data collection. The next step is what? Data analysis. The next step is what? Data interpretation. And then the other one is what? Conclusion. That's the 7 steps. And I want to tell you, in solving real-life problems, we're using engineering knowledge where you follow those 7 steps. In Form 1, you just mention and claim them. In ordinary diploma, you will use them to solve a particular problem, whether you like or you don't like. Remember that to learn what we are going to teach you, it's not an option, as long as we're students in that particular course. Right? Yes. Are we together? Yes. So, for this case, it means you should have to know how you can use this technique drawing knowledge to interpret. So electronic drawing, which have been drawn by other technicians or other artisans or other engineers or other professional engineers. So you have to be able to interpret, to interpretate. So you should not only be able to draw, you have to be able to read what has been drawn by others. Are we together? Yes. In these 6 sub-enabling outcomes now, once you know how to interpret it, even yourself, you can draw or you can do some simple drawing. And these simple drawings, that's what we call it, to produce. Say to produce. Say to produce. To produce what? Electronics drawing. When you'll be constructing what? Electronic circuits. Or when you'll be analyzing electronic circuits. Class, are we together? Yes. So simply you have seen here the vocabulary called the knowledge. Say knowledge. Knowledge. In this course, actual, in every lecture, I will teach you how to extract your knowledge. Say knowledge. Knowledge. And in this knowledge, I will teach you how to understand it. Then we have another important keyword called understanding. Say understanding. Understanding. Say understanding. And then the last terminology, which is powerful in welding, will teach you how to extract your wisdom. Say wisdom. Wisdom. Say wisdom. Wisdom. Simply, knowledge means information. Say information. Say information. Understanding means comprehension. Say comprehension. Say comprehension. Wisdom means application. Say application. Say application. Say application. Yes, that's why the King Solomon has said that wisdom is supreme above all. So within these three terminologies that are changing the world, that we are living today and even tomorrow, and even in future, these are the three words that are changing the world. Knowledge, understanding, wisdom. Knowledge, understanding, wisdom. Knowledge, understanding, wisdom. You came here to seek knowledge, understanding, wisdom. Every day, seek knowledge, understanding, wisdom. And this is the very challenging part. If you want to know that this is the very challenging part, ask your neighbor, how many information do you have in your mind? Ask your neighbor, how many information of science and mathematics do you have in your mind? Answer that question. Ask your neighbor, don't write those keywords. How many information do you have in your mind or in your memory? The next question, how many of those information that you have comprehended, that means you have understood? You'll be asked that few. And ask another question, how many of the information that you have understood you have applied? Yes, take a simple example of physics. You have so many information about physics. How many of them that you have understood? How many of them that you have applied in your real life? So you may find that within 4 years, what you've been learning is just the information. And they have nothing to understand, and they have nothing you have applied. So even in these 3 years, if you won't be serious and change your mindset, you will experience the same situation. You'll be ordinary diploma graduate, but with information, which you did not understand and which you don't know how to apply. Class, are we together? Yes. Are we together? Yes. Yeah. So in this course, I will try my level best whenever we have a chance to meet, to deliver to you knowledge, to deliver to you understanding, to deliver to you wisdom. I can just give you a simple example to illustrate about these 3 words. A medical doctor knows about the negative side effect of smoking a cigarette. Are we together? Yes. So he knows, he has the information about cigarette, the negative effect of the cigarette. And then he has been taught from nursery school to maybe specializations in medicine. So he understood the information, right? But how many times have you ever found a smoking medical doctor? Several times. How many times? Because even alcohol also has a lot of negative effect in our bodies. And the medical doctor has learned all of those. How many medical doctors that you have found that they are taking alcohol? So many. So they have information, they have knowledge, they lack what? They don't apply what they have learned. Simple. Are we together? Yes. Are we together? Yes. Are we together? Yes. For instance, let us come to you. How many of you know logarithm? Raise up your hand. Raise up your hand if you know logarithm. Oh yeah. He's not in the class. So you know logarithm, right? How many of you have understood how to solve some questions of logarithm? Few hands. How many of you have applied solving logarithm in real life? Maybe at home, maybe at school, maybe in hospital, maybe in car. How many of you have applied?
Maybe.
There's no maybe. The answer is just simple. I have applied or I have not what? We don't have politics in science. Right? Yeah. So you have so many information about logarithm. You have understood to solve the question. But you didn't understand where do we apply. Are we together? The same story for electronics and telecommunication engineer. If you want to change your mindset, you will have a number of information. Few of them you will understand, few of them you will cram, and much of them you will cram. But you may not apply and you may not know any of those information in application. Remember that everything that we have in the world, it has particular application. So if you don't know, it's a matter of you. Not it's a matter that everybody in the world. Are we together? Every discovery that we have in the world, it has a particular application. It's a matter of you to learn or it's a matter of you to live it. Are we together? Yeah. So this is the challenge I want to leave it to you when we are going for the break. Make sure that you think how to get the information, how to understand it, and how to apply it. Before we go for the break, in case you have any question about those sub-enabling outcomes and what I've taught, raise up your hand and ask it. Class, it's a time for you to talk. You have a question about what I've presented there? First of all, did you understand? Yes. Did you understand? Yes. Did you understand? Yes. So if your mother or your father asks you that, what did you learn today? Can you share with them? Yes. Or you read for them? Can you share from your brain or can you share from your exercise book? Ask your neighbor. Okay, so before we move into the next part, just to sit here. This is the chair that you have to sit. Oh, it's not okay. Okay. So before we move into the next part, which is the third part of this general introductions of electronics drawing, right now I would like to ask all the students to make sure that to read. Yes, because this is the vision of this model. This is what we are going to discuss from the first week to the last week of the semester. However, that I might teach you some skills which are not stated in these sub-enabling outcomes, but I want to tell you that we'll be paying our attentions onto these six sub-enabling outcomes. So you have to make sure that you remember yourself, and every time we cover a particular concept, you have to question yourself. The concept you have learned is actually achieving which sub-enabling outcome. So because you want to reinforce the understanding, then I would like to ask all the students to pronounce or to read all those six sub-enabling outcomes happily and with a great expectations of enjoying electronics drawing. Then we'll move into the third part. So I'll be counting 1, 2, 3. Then we read from the first one to the sixth one. But you should not just read because you are reading for me. Read because you are writing in your mind. So even if that we meet in Mendokas, or we meet in the streets, or maybe in the departments, I can ask you, can you mention the second sub-enabling outcome? You should not tell me that I forgot. You should not tell me that I wrote on the exercise book. Well, you wrote on the exercise book, just wait. You wrote on the exercise book, but it's a time for you to transform what you have wrote in the exercise book to be in your mind. Are we together? We say that we have knowledge, understanding, and the wisdom. In order for you to apply this, the first step, you have to keep in your mind. You have to think how to apply. That's what the information. You have to understand them, and you have to apply them. Okay? 1, 2, 3. Let us go. No. That's not the voice of 46 students. 47 students right now. 1, 2, 3, 4. Go. Electronics drawing knowledge to describe electronics drawing in constructing electronic circuits. The second one. Use electronics knowledge to interpret components systematically in electronic circuits. The third is enabling outcome. Select And the first one? You're not pronouncing. No, you're not pronouncing. The subnaming outcomes are there on the blackboard. You are not pronouncing. The fifth one?
Use technical drawing knowledge to interpret electronics drawing in servicing electrical and electronic circuits.
The sixth one?
Electronics drawing tools to produce electronics drawing in constructing electronic circuits.
The three key terminologies? Again, the three terminologies?
Knowledge, understanding, and
Again, say it loudly. Okay. Well, so if that's the case, I believe that you have understood about those 6 sub-enabling outcomes. About actual, I believe from now onwards, you won't be blind in case of electronics drawing. So now the next part, which is very important, this is number 3. We call it prerequisite module. Prerequisite module. Say prerequisite module. Say prerequisite module. Say prerequisite module. How many of you have gone through pre-unit? Raise up your hand if you have gone through the learning. We call it pre-unit. Raise up your hand. You should be happy. That's how. Just a pre-unit. Raise up your hand. You have gone through pre-unit. You haven't gone through pre-unit? You just gone to what? Kindergarten school? So pre-unity means that it's a early education or it's a prior knowledge. When you talk about prerequisite module, say prerequisite module. Say prerequisite module. What does it mean? Actually, prerequisite modules mean that we would like to present to you, or the curriculum has to state, which module should you know before you learn electronics drawing. Let me repeat. Stop writing, I said. Prerequisite module, it means that this is the prior knowledge, that prior module you have to learn before learning electronics drawing. So in case of all the modules of first semester in NTA level 4 or first year ordinary diploma students, all of the modules, they just have non-prerequisite. But once you get into the second semester, you find that most of the modules that you learned in the first semester are the prerequisite of the modules of the second semester. Is it clear? It's not clear. Listen. Let me just refer just one of the subjects that we call the basic mathematics, Form 1. Basic mathematics in O level. So in basic mathematics in O level, we had a topic that called the coordinate geometry. We had taught you coordinate geometry in basic mathematics Form 2. And also we have taught you coordinate geometry in basic mathematics Form 4. So what does it mean? The prerequisite knowledge of the coordinate geometry of the Form 4 is coordinate geometry in Form 2. Is it clear? Class, is it clear? Yes. For instance, we learned another topic that called statistics in basic mathematics Form 2. But also we taught you statistics in basic mathematics Form 3. So the prerequisite topic of statistics in basic mathematics Form 3 is statistics in basic mathematics Form 2. Are we together? Yes. Are we together? Yes. Are we together? Yes. Well, we taught you another topic in physics that called the current electricity in physics Form 3. But we taught you current electricity as the second topic in physics Form 2. I'm teaching you according to what you know, the information that you know. The good thing that I thank God by His own grace, I'm also a physics teacher from Form 1 to Form 6. I am a basic mathematics teacher from Form 1 to Form 4. I'm also a teacher in advanced pure mathematics, Form 5 and Form 6. I'm also teaching chemistry from Form 1 to Form 6. So all the information that you know or you have been learning, for me, I apply them every day in my life. So you might have forgotten, but for me, I cannot forget, because that is actual data I need to use in order to teach people. Are we together? So prerequisite modules means that the prior module, before you learn that particular module. Are we together? So there is no prerequisite module for this module. That's why I wrote 20, none. Okay? A? The prerequisite subject for physics Form 2, is physics Form 1. The prerequisite subject of physics Form 3 is physics Form 1 and physics Form 2. The prerequisite subject of physics Form 4 is physics Form 1, physics Form 2, physics Form 3. Are we together? Yeah. That's why you cannot learn physics Form 4 and then as a first subject when you get into secondary education, and then you learn physics Form 1. Is it possible? Is it possible to start learning physics Form 4 and then you come to physics Form 1? No. Right? Class, are we together? Are we together? Yes. So in every module, there is a prerequisite module. Number 4. Number 4, we say that learning context. Remember that all of this information I'm presenting to you is according to DIT curriculum. So learning context. Learning context. Say learning context. In this learning context, we are the teachers. We are being guided to on how we have to deliver the concept. So then, according to the curriculum, it states that this module of electronics drawing will be taught. Through lectures, just like the one that I'm teaching you, through workshops. Our workshop for this module will be actually the drawing or doing the workshop, the hands-on workshop and computer simulation workshops. And then also this module has to be taught in practical works. However, the practical works that we're going to do is actual practical works which we are going to discuss. We are going to teach you on drawing. Then this module has to be taught through tutorials, and also we say that this module has to be taught through assignment. Some of the concepts you have to be taught through assignments, and also should be taught through independent works. So actually, you may notice that lecture is the first method, workshop the second method. This one is practical works is the third. This is fourth. This is fifth. And this is sixth. So we have almost 6 learning contexts. Are we together? Say lectures. Say lectures. Say workshops. Say practical works. Say tutorials. Say assignments. And independent works. Say independent works. Say independent works. Then number 5. Number 5 are learning materials. Learning materials. So what are the learning materials for this module? The first learning material is textbook. Textbooks. The second learning material is manuals. The third learning material for this module that you need to have is whiteboard. It means for teaching. Also, the next learning material that you need, blackboard, in case of teaching. Also, another one, so you need other learning materials, means that papers. This is for electronics drawing. Then sometimes you might need graph papers. And then another learning materials, we call them computers. And then another, yes, these are the materials that you need. So how many learning materials you need in order for you to learn about electronics drawing? 7 materials. So the first one, say textbooks. Say textbook. Ask your neighbor, do you know textbook? If the answer is yes, ask him or her to mention at least one textbook that. Mention at least one textbook to this friend. How about your neighbor now? The memory reads at 0. 0 KB. File is not full. Ask your neighbor, up to now, this is the 3rd week. Which textbook do you have of electronics? Ask your neighbor. You say that you fall in love with electronics and telecommunication engineering. And then tell your neighbor, one of the signs to show that you are really serious to have textbooks in OT, electronics and telecommunication OT engineering. So ask your neighbor now. It's a time to talk to your neighbor. Tell me one textbook that you have in electronics and telecommunication engineering. And once that you tell it to your neighbor, show him or her. In case you forgot it at your home, you have to give him a promise or her. I will bring it next Monday. So you don't have textbooks. What do you have? You just have smartphones. Exercise books. And bags. Then you, as a serious electronics and telecommunication engineer, you should have manuals. Say manuals. Ask your neighbor, do you have any electronics or telecommunication manual? And then the other ones is whiteboard. Well, so this whiteboard is for teaching. And the other material is blackboard for teaching. Then you have papers. Ask your neighbor, do you have a special papers? Or do you have electronics papers? You have a question? Okay, wait. Then the other one is graph paper. Say graph papers. Graph paper. Ask your neighbor, do you know graph paper? Where did you use graph paper? In physics form 4, isn't it? You do what? Graphs. Of what? Mechanics, light, and the current, electricity. So ask your friend, your neighbor, do you have graph pad? Do you have graph paper there as a serious and practical electronics and telecommunication engineer? Ask him or her. Do you have graph paper? So if you don't have a graph paper, it's one of the signs that you are not a serious electronics and telecommunication engineer. Yes. Electronics engineering and telecommunication engineering is all about diagrams, it's all about tables, it's all about graphs, It's all about the formula and the equation. And it's all about what? It's all about the results. So we have so many graphs in electronics and telecommunication engineering. But you don't have even a graph paper to draw one of them, even to copy. So you have noticed that your neighbor does not have any of these learning materials. Does your neighbor have it? No. Then the other one is what? Computers. Ask your neighbor, do you have a computer? If the answer is yes, show me. Then the other learning material, that this is number 8. This is just the additional. In order for you to learn about electronics drawing, you need also to have material, we call them data sheets. Say data sheets. Data sheets. Say data sheets. Data sheets. Say data sheets. Data sheets. Let me explain about textbooks. Textbooks is actual. This is the book that teach you about particular concept. It has been arranged in terms of the chapter 1 to the last chapter, but also it has a learning part, and maybe it can have some questions at the end of the topic. For instance, basic mathematics, book 1. It's one of the textbooks. It teaches you a lot, and then gives you some exercise at the end of the concept or at the end of the topic. In learning or in engineering, we have textbooks and question and answer books. So textbooks is actual, give you descriptions or explanations about particular concepts and give you some questions at the end of it. Question books are focusing on the questions, just to give you questions of the particular topic. When we talk about manuals, this is a very important electron. Say manuals. Say manuals. Okay. Whenever you have a mobile phone like this one, or whenever mobile phones that have been like this one have been made, it cannot be sold without the user manual. Say user manual. Yeah, so whenever you have a mobile phone, usually in Tanzania, we don't ask user manual. You just need a mobile phone and just a charger, maybe some earphone, that's all. And should be put in the box to know that it's new brand. Okay, that the means of 40 manual. So in electronics, maybe you wanted to learn about drawing a particular, maybe a particular amplifier, an audio amplifier. So then you want to maybe to draw a schematic circuit diagrams of particular commercial amplifier. So you need to get the user manual for that amplifier or for that particular device. Maybe you want to draw the schematic circuit diagrams of camera, mobile camera. It means all cameras that you use in mobile phones. You want to draw it, so you need to have a user manual. And when we talk about papers, we mean that we have, in engineering, we have A5 papers, we have A4 papers, we have A3 papers, we have A2 papers, we have A1 papers. That's the meanings about these papers. Whenever you talk about graph papers, you're familiar with them, that they have actual vertical lines and horizontal lines, very important. And whenever we talk about computers, these are the electronics devices that used to simplify the human world. Okay? Okay? Yeah. My friend there, Musa, had a question. Welcome. I've already answered. Thank you very much. Any students who have a question about what we've discussed? Say data sheets. Say data sheets. Manuals or user manuals, we call them, these are the manufacturer's mind on how to use electronics device or telecommunication device or electronics equipment or electronics tool or telecommunication equipment or telecommunication device or equipment. That's the means of user manual. So user manual is focusing on how to use it. Hello, Restuta, it's time to receive the new information. That the means of 40, user manual. Manufacturer's mind on how to use, not on how it has been designed, not on how it has been made. Are we together? Yes. That the meaning of what? User manual. And the idea of user manual, it has been originated from God himself. Say God. Say God. Actual God has created a one man and two people within a one man, who is called the Adam and Eve. And then God did not explain how he has created the human being. But he just given a human being a user manual. If you wanted to prosper, follow the following rules. If you wanted to fail in life, don't you follow the following what?
Mungu ibariki Tanzania, dumisha